Assalamualaikum warahmatullahi wabarakatuh. My name is Loman Hakim Bazakara from Group EE2414C. Today I would like to discuss about my LAB report for the subject ECE521. This LAB report is about ARM assembly language programming, data transfer, data processing, and addressing modes. The objective for the laboratory works is to write simple assembly language for the ARM microcontroller using data transfer, data processing instruction, and addressing modes, and to execute the program using an ARM kill editor, assembler, or using the simulator. So let's take a look at the very first questions. Write a program that will store 0x30 into R0, copy the content of R0 into R5, and then save data 0x45785612 into memory locations 0x4000030. Execute the program and explain the difference in the results. Also discuss the addressing modes of each instruction used. So let's take a look at the first questions. Let's wait for a while. As you can see, this is my coding for the question ones. So let's build it first. As you can see, there is no error, so we can start debug the. As you can see, the value in the register is random because we not use step the line to execute the command. We use the MOV command to store value of 0x00000030 into the R1. As you can see, the R1. So let's take a look at another one. So as you can see, the R5 have the same value of the R0, which is 0x00000030, because we use the MOV command to copy the data from the R0 into the R5. Next, we use the LDR command to store value of 0x45785612 into the memory location of R1. As you can see, the R1 has its value changed into the one that we want. Next, same as the R2, we use the LDR command to store value of 0x40000030 into the R2. Next, we will use the str command to store memory data from R1 into the R2. As you can see here, this is the data from the R1 that have been put into the R2. Next, as the question wants, also discuss the addressing mode of each instruction used. For this instruction line, we use the MOV, which is the immediate addressing modes. For the second line is register addressing mode, and the third line is immediate addressing mode, same as the first line. The fourth line is also same as line above, which is immediate addressing modes, and the last line is indirect addressing register tracks. So that's for the question 1. So let's take a look for question 2. Write and execute a program that will add 0x20FE5690, 0xFE123, 0x9, and 0x345 at 9710, and save the sum in register R7. record the changes in CPSR as well. So let's take a look at the second question. Let's wait for a while. Sorry for the convenience. So this is my coding for the question 2. So let's build it first. Same as the question 1, there is no error. We can start debug it first. So the R0 has a value of 0x20FE 5690 because we use the LAR command to store the value into the R0. Same with the R1, have the value of 0xFE123089 because we use LAR command to store the value into the R1. For the R2, we also use the LDR command to store the value of 0x34589710 into the R2. And we use the ADDS command to add R0, R1 and store it into R3. And also we use another ADDS command between R2 and 3 and store the data into the R7. So this is the result. So let's take a look at the third question, which is write a program that will store 0x2936 FEDA in R8 and then perform the following instruction on the content of that register 4 times. Comment on your result. First is ASR, second is LSL, and third one is the ROR. So let's take a look at the coding for the question 3. So this is the coding for the question 3. So let's build it first and see if there is no error and we can start debug it. First, we use the LDR command to store the value of 0x2936 FEDA and store it in R8. And next, we use the ASR command that rotate the value of R8 4 times and store it into the R1. As you can see, the value is changed into 0x02936 FEDA. To show this, we can use the calculator. 2936 FEDA. Shift. So this is rotate from the right 4 times. As you can see, it has the same value 02936 FE D. For the next comment is the LSL. So we shift from the left of value R8 4 times and store it into R2, and the value is 0x936FEDA0. So we use also the calculator. 936FEDA left 4 times. As you can see, the value is same, which is 936FEDA0. And the next command, we use ROR to rotate the value R from R8, which is 0x2936FEDA 4 times, and store it into the R3. So as you can see, the RT has a value of 0xA2936FED.